All right, got my recording started. Perfect. Let's get going. All right, just a reminder, everybody, I would like your cameras on. I appreciate that. It lets me know that you are here and you're trying to do the class with us as a group, okay? And I will be counting it as an absence if your camera's off during class. Alrighty, so we have been doing functions for about a week now. On and off, right? We've also been doing domain and range and kind of mixing it up and going back and forth. Then last week on Wednesday, I started this new concept of function notation. So we're going to dig into that again today. And today's going to be kind of a reminder on what that means and then how to evaluate functions when they're in function notation. So just a friendly reminder, everyone should be taking notes. And at the end of class today, I'm going to be giving you your homework as 2 problems to do on paper to at least attempt them. And then you'll send that to me as a picture later through Google Chat when you get it finished. So, Davey, good morning to you. I need you to turn on your camera, Davey. And if you don't have it turned on, it's going to count as an absence in class, okay? And Victor, I hope you can hear me, bud. I'm glad you're here. I would like you to turn on your camera, please.
Yeah, sure.
Thanks, Victor. Thank you. Davey, can you hear me, bud? No. Okay. All righty. Here we go. A quick review before we get going. So evaluating functions, we talked about this again yesterday. What does it mean if I ask you or the curriculum in a book or Edmentum asks you to evaluate a function? Anyone want to take a stab at this? In your own thoughts, in your own words, what does it mean to evaluate a function?
It means to, wait, can you hear me?
I can hear you great. Go for it, Anaya.
It means to plug in a number for whatever variable it wants you to find.
I love it. Absolutely. Let me see if I can write down exactly what you said. Evaluating functions means plug in a number for whatever variable it asks you to find. Usually it's going to be X. Okay. I'll be honest with you guys. Usually it's going to be we're plugging in a number for X. But let's be ready in case it's something else. Plug in a number for whatever variable it's asking you to find. Thank you, Anaya, for sharing that. Love it. It's a fancy way of saying plug in a number and solve for the other variable. Normally, it'll be we're plugging in for X, but be ready. Maybe it'll be different letters that they're using instead of X and Y. Sometimes they throw us for a loop, and it's really going to be C and D or A and B or some other weird variables. Usually, it's going to be X and Y. Now, here's another one I wanted to review with you, and it's been a while since we've talked about this. Function notation means we write our function. I'm going to make an example. This is f of x, and I'm just going to make up an example, okay? 3x plus 1 instead of y equals 3x plus 1. Okay, it's a different way to write our function. We're writing it with f parentheses x. And here's a reminder on how we say that. F of x. F of x. I know your mics are off, and that's okay. I want you to practice saying that with me a few times right now. F of x. You can say it with the mic off. That's all good. F of x. Just practice alone. No one can hear you. A lot of times, this math vocabulary can be kind of intimidating. And I want you to just practice at home, by yourself. No one can hear. No one's judging you. And you know what? Take solace in the fact that we're all saying it at the same time. F of x is equal to 3x plus 1. And we'll do more work with function notation in just a few minutes. All right, I saw we had a couple other people join. Let's see here. All right, so let's see. Joseph, are you back yet? Thanks, Joseph. So Anthony Torres, welcome to you. Thanks for joining today. And then Alyssa also joined. And Davey, I don't know if you can hear me, Davey, but Alyssa and Anthony, yesterday we talked about some new rules, new norms that I'd like everyone to do in this class. And one of those is to have everyone turn on your cameras during class. Okay. I appreciate this because it lets me know that you're actually here. So going forward, I'm counting it as an absence basically if your camera's off. So if there's some special circumstance, then we need to work that out privately. I don't want to blow anyone's private info up in front of everyone. So if there's some reason that you don't feel comfortable today doing this camera, or you literally can't do it, let's talk about that later. Okay, we need to figure that out. So today I'll give you this one day of grace, but everyone else knows that this is the new rule. And starting tomorrow, it is going to count as an absence if your camera's off. Okay, so I just want you to know that. And if you can turn it on today, Alyssa and Anthony, I really appreciate you doing that. It lets me know that you're here and following along. Okay, so that's just a quick review on evaluating functions and then function notation. Let's do some practice evaluating. We left off with this example yesterday, and we ran out of time, so we didn't get to do too much of it. This says, find the range for the following domain values, and then it gives us a list here of domain values. In the function, and here's the function, y equals 5/3 x plus 2, 5/3 times x plus 2. When we have a number written right next to a variable like x and the 5/3 is here, it's implied that it's being multiplied. Okay, there's no symbol there for it, but we know that that means being multiplied. So 5/3 x plus 2. Find the range. That means, okay, it's a little late, but I'm going to let Hey, Billy, is that you?
Yeah.
Okay. Hey, thanks for joining. I wanted to have everyone join a little earlier, so but I know that yesterday you were trying, and I don't want to punish you for being late, especially if there's a legitimate reason. So come on in. Thank you. And just know that I am asking everyone to turn on their cameras going forward in class. Okay.
Mm-hmm.
Thank you, Billy. So you haven't missed too much. We're just doing a little bit of evaluating functions. And we actually left off with this one yesterday. So this will be at the end of yesterday's video. So find the range means find the outputs. Remember, range, outputs. Domain, inputs. Numbers we'll plug in are the domain. Numbers we get out are the range that go with those domain values. X's, inputs, and domain all go together. So whenever you see the word domain, that means like the group of X's. And that means range goes with the y's. So we're looking for output numbers. Those are the y numbers. So our answer will be a list of numbers that we get out after we plug in all these guys on the right in our list for the different x values. Now, this is a good example, I think, because it gives us a lot to work with. We've got a fraction, we've got to multiply a fraction, and then we're making a list of output numbers. So let's do that now. So yesterday we did plug in negative 12. We'll do that again real quick. So we're taking our whole function, 5/3 times x plus 2, but we're plugging in or substituting the first x value, the first domain value in for x. Now remember, when we're multiplying a fraction to a whole number, essentially what we can do is multiply the top times the whole number. So that's going to be 5 times negative 12. So pull out your calculator, and you should get negative 60. 5 times negative 12 is negative 60. You're also going to bring with it whatever came in the denominator of the first fraction, so 3. So we've got negative 60 over 3. Now check and see if we can divide that. Check and see if that negative 60 over 3 reduces or simplifies down to something smaller and nicer to work with.
We can. Negative 20.
Negative 20, totally. So we get negative 20 plus 2. So we plugged in a negative 12, and we're going to have negative 18?
18.
Okay, over on the right side of my screen, I'm going to make a table to kind of keep track of our inputs and outputs. We've been using tables a lot in this group. Let's continue that. We plugged in the negative 12, and we got out negative 18. Now, what we need to do next is all the rest of these values. I want to plug in negative 3, 0, then 3, and then 12. Okay, I'm going to make some space around our first problem so we don't get it mixed up with it, hopefully. Now let's try plugging in negative 3. So I'm going to start at the beginning, except we plug in negative 3 instead of negative 12. Like last time, 5 gets multiplied to whatever the whole number is. So that's negative 15. Then we divide, and this time we get negative 5 plus 2. And that'll leave us with a y equals negative 3. Now back on my table, keep track of that information. We plugged in negative 3, and interestingly, we also got out negative 3. Okay, I'm going to box that work so I don't mix it up with the new work. Here we go. Now we're going to plug in 0. Y is equal to 5/3 times 0 plus 2. Now this is my favorite because the 0 times the fraction makes it go away completely. 0 times anything is 0. Y is equal to 2. So we're almost done. We found 3 outputs. We need to find 2 more, and that'll be the whole range to match up with that whole domain. I'll box this work so I don't mix it up with the new work. Okay, so here we go. Y is equal to 5/3 times 3 plus 2. So we get 15 over 3. And that comes out to 5. Remember how I'm getting that 5? We're doing the division. Try it in your calculator just to check and see. 15 divided by 3 comes out to 5. All right, and this time we get a 7. Okay, we're almost done with this. Are there any questions or concerns? Anything you noticed that you'd like to point out? Please. Let's finish it up. We're going to plug in a positive 12. Okay, so we did 5 times 12 earlier. It's 60. 5 times 12 is 60. And then we also found that 60 divided by 3 is 20. But it's not negative, right? It's positive this time. 20 plus 2 is 22. And there's our answer. So how we would list this off will be as a list form. If you just showed me this table, I would understand that and be like, oh, okay, so here's their range, their output numbers to go with their input numbers. That's perfect. Honestly, the table we made for me is completely good enough. I love it. In Edmentum, though, if we're ever doing a mastery test or a post test, they may want to see it exactly the way it came. So they gave us a domain list. So our range list, I'll write at the top here. We're going to use those fancy brackets, and then we're going to list off the numbers in the same order we got them with the domains. So negative 18, negative 3, 2, 7, and 22. And hallelujah, we're done. We found 5 different outputs to go with those 5 inputs, 5 domains. Now, I did choose kind of a harder function on purpose. I wanted to practice using this fraction. They won't all have fractions, okay? But we should be prepared for all of them. I have another one here, and I'd like to make, let's do this. I'd like everyone to try starting this one on your own. Okay, you know what? I got a little ahead of myself. Let's just talk about function notation real quick. And then we're going to try our next example. Okay, so like I said in the beginning, function notation, just another way to write our functions. So instead of y equals a function, like for instance, let's go back to that last one we had. It was 5 thirds x plus 2. Here's the last function we just worked with, 5 thirds x plus 2. We write it like this, f of x, 5 thirds, x plus 2. The only thing that's different is how we write it. And this doesn't mean f times x. It means the function, its name is f. Function's name is f. And the inputs are all x's. It's very technical. Inputs are x's. It's like we're splitting hairs here. If you're wondering, why do they bother with this? Why do we have to have a new way to write our function? Technically, it's so that we can have many functions at once that all are related, but they'll have different names. So for instance, just an idea of why we have these different, why we use function notation. Let's say I had a lot of different data and I wanted to graph it all together. So here's my first function. This is like f, let's say, f of x. And then I have got another one here that goes with it, but it's different information. So maybe this will be h of x. And there's a third one popping out. It's this one here, g of x. So here's one reason why we use function notation. So we can put all the data together, graph it all at once, but they can have different names just so that we know, like, okay, does that go with the first one? No, that's the g function and the f function and the h function. But they're all using the same inputs. They're all using the same x values, not different inputs, right? So that's one reason that we use function notation, is to keep track of our functions with different names that have the same inputs. Any questions, concerns? Please. Okay, so for the rest of today, and honestly, a lot of what we're going to do in the rest of Math 1, we're going to be writing our functions in function notation. So f of x. So here's another one I want to try. Here's example 2. It's just like example 1 that we just finished together. Find the range for the following domain values. These are the inputs. And the function is f of x is equal to 3 halves x plus 4. 3 over 2 times x plus 4. So here's what I'm going to do. I want to put everyone in a small group breakout room. I want you to try plugging in these values and solve it together. I gave you 6 different domain values. Let's see how much we can get done in just a few minutes. Maybe we can get at least 1, 2, or 3 of them finished and find range values. And I'm going to come around to the different rooms and check in on everyone's progress. Okay, so if we don't get all 6 finished, that's okay. But let's see how far we can get. Let's try doing these together. So I'm going to make some breakout rooms, and I want you to try working together on these. You can split up the work. You can do them as a group, one at a time. Okay, just 3 people in a room. So go ahead and join the different room that you're going to get the invite for. And if you need to write down this problem first, I don't blame you. Go ahead and write it down. I'll come around and give you any sort of reminders or hints that I can, okay? All right, just a reminder, everyone should copy down the problem, or at least the function and the domain, and then take that with you to your breakout room. Start solving it with your partners. Okay, so let's see here. Savannah, are you there? Can you hear me? Or Moose, can you hear me, Moose? How's it going? And how about Brooke? Brooke, are you there? How's it going, Brooke? Okay. Barracat, are you there, Barracat? Davy, can you hear me, Davy? Philmon, are you there? Interesting. Okay, you three. Uh, Anthony, I hope it's okay. I moved you over to this group since I noticed the other students didn't join with you. Did you three, did any of you write down the function or the inputs, the domain that we'll be using?
No,
No. Okay.
I was in the bathroom. That's why.
Oh, it's
Sorry.
okay. Sorry about that. Let's here. Can I share my screen with just you guys? Okay, can you see my screen again, folks?
Yeah.
Okay, cool. So write this down. We have our function at the bottom. That's f of x equals 3 over 2x plus 4. And then we're given a list of domains. Those are going to be the inputs. We're going to plug those in for x, solve it, and then hopefully get an output number. That's the range. Basically, it's our list of outputs. Let me write that down here. Now, if the negative ones are too scary to start with, I don't blame you. Start with the positive ones. Start by plugging in 0 and see what we get. Plug in 2 and see what we get. And then once we've tackled all those, maybe we can back up and try the negatives. Billy and Anthony, are you guys there? Can you hear me? Okay, Anthony, can you turn on your camera and work with Savannah and Billy on this? Okay. Well, I understand and I'm sorry that you're not feeling good, but now Savannah's got to do most of the work on her own if we're not going to be able to work together. Billy, are you there? Can you hear me?
Yeah.
Billy, you doing okay, Billy?
Mhm.
Awesome. Thank you for turning on your mic and answering. Can you work with Savannah on this and try plugging in some inputs to get the output numbers that go with them?
Mhm.
Okay. I want you guys to work together. So if you don't want to split them up, why don't you just talk about what do we get when we plug in 0? Let me start you off. So I'm taking the function from above. I'm switching out x with one of the input numbers, the domain numbers. So f of 0 is equal to this on the right. Well, now we need to multiply, add, get our answer. Then we're going to start over and do it again with 2. F of 2 is equal to this business. 3 halves times 2 plus 4. Anthony, since your voice is not feeling well, I want you to try these as well. And you guys should be able to chat with each other in the breakout room. So send the Savannah and Billy some ideas or your input through the chat, okay? I'm going to check on another group. I'll come back in a few minutes and I want to see if you guys have been able to find the answers or at least some of them, okay? See how far we can get. Hey, Moose, how's it going? Moose, if you're there, I'm going to move you to a different room. There we go. Okay. Hello, everybody. Victor, Anthony, Moose, how's it going here? Hey, Savannah, is everything okay?
Sorry, I didn't mean to do that.
Oh man, I thought you guys.
It
That's
was
all
an
good.
accident.
I'm glad it worked. That's cool. All right, let me check on another group. I'll be right back with you folks.
Okay.
Okay. Okay. Hey everybody. Anaya, Joseph, Davey. Davey, you made it in. That's good. Folks, I'm not sure if everyone got it written down before you went to the groups. Have you been able to work through any of these and get any outputs yet? Or do you need me to share my screen and show you the problem again so you can write it down?
I have one output because I'm working on the second one.
Anaya, that's awesome. Good job. Joseph, here's that screen again. So check this out. Thank you for telling me you needed it. What's important is our list of domains. Those are going to be the X numbers. Let me write that here. X numbers. And then below that, we've got our actual function. F of X is equal to the rest of it, 3 over 2 times X plus 4. I set these up just to show what it will look like when we're plugging in 0. And then later we plug in 2. One thing I'm telling all the groups is to, if you're uncomfortable taking that step and trying the negatives, at least try the positives and we'll have that to work on. Okay, we can plug in 0, 2, and 4 and see what we get there. And then if you're feeling up to it and ready, I want you to try plugging in those negative numbers. Check your work with each other and say, hey, did you plug in -8 yet? Did you plug in 0 yet? What did you get? It's okay. If you guys really don't want to turn on your mics, at least use the chat function. You should be able to chat to each other. Let's see. How do I get back to this? Okay, I need to check on another group. Are there any other questions that I can help with right now? All right, well, I'll come back and check in a minute. You guys try to get some of these inputs plugged in and get an output, okay? Levi and Tira, how we doing here?
We found the ranges.
You done?
Yeah.
All right. Well, hats off to you both. What'd you get?
So, Levi, did you want to tell him or?
Yeah, I can tell him. So we all we did the problems on our own, and then we checked to see if we got the same ranges, and we did.
Sweet.
So the first one for -8 would be -8. -4 would be -2. -2 would be +1. 0 would be +4.
Mhm.
+2 would be +7, and then +4 would be +10.
Oh, I love it. Thank you so much. And you checked with each other.
Yeah.
Nice job. Well, thank you both for doing that. I'm going to check on the other groups. If you want to take a quick break, you can. I don't blame you. But then I'm going to pull us all back to the main room, okay?
Okay.
Okay.
Thanks for your hard work today. I'll be right back in a sec. Okay. Victor and Anthony and Moose, how we doing here? Did you folks manage to find any of the outputs for the inputs given in that domain? Or do you need to see the page again? Awesome, Anthony. Does anyone need to see the function in the domains again? Okay, Moose, thank you for telling me. So here it is. Just one sec. Here's the page. What's important is the function. That's the equation at the bottom. And then we also need the domain values. That's like our list of X numbers, inputs. Find the range for these inputs of this function. And I started setting it up in the middle here. If you plug in 0 from our list, f of 0 is equal to 3 over 2 times 0 plus 4. And then below that, if we plugged in 2, here's what that would look like. I didn't work it out, but that's like set up. If you're not comfortable trying those negative ones, at least try the positives and see what you get for those. Now, also, folks, if you're not comfortable talking to each other with your mics, I get it, but I would really encourage you to take that risk and just try saying, hey, Anthony, did you get this number when you plugged in 0? Or, hey, Victor, did you get this number when you plugged in -8? And talk about it with each other. The worst that could happen is, they don't answer. Like what's happening to me right now. So just give it a shot. Or you can use the chat, right? You can chat to each other. That should work, and you should be able to chat with each other. I'm going to try another group and check in with them and see how they're doing. But I want you guys to give this a shot, see how it goes, see if you can get any of the outputs, the range, okay? And if you get stuck, ask your partner for help. Okay? I hope you're doing well. I'll see you in a minute. In a few minutes, I'm going to pull everyone back to the main group, I think. Okay, I'm back with you, folks. Savannah, Billy, and Anthony. Did we get any of those inputs? So did we start any? Did you try any and see what you got?
I tried the -8.
Sweet. And let's see here. I'll pull up mine so we kind of follow along with each other. Okay. So you plugged in -8.
Mm-hmm.
What did you get? Or where did you get to, if you don't mind sharing?
You want the answer?
Sure. What did you get for your answer?
I got 16.
Let's see. That sounds right. Let's see. Let me just double check with you because I didn't actually write all these answers down for myself. So 8 times 3 for that fraction times the whole number will be -24.
Mm-hmm.
Okay. -24 divided by 2, if we try that in our calculators, we get 12, -12, right? Oh,
Yeah.
snap. I see where you got the 16 from. 12 plus 4 would give us 16. So I think maybe, Savannah,
Mm-hmm.
perhaps you lost the negative sign at some point.
I didn't do a +2. I did negative.
Oh, okay. No worries.
24.
Well, then you did it right. So from what you had started with, you did it correctly. You canceled your negatives, didn't you?
Yeah.
Oh, Savannah, I love it. High five. Nice job. So for what you started with, you did it correctly. I made it maybe too small to see all this writing and stuff. So you missed that. You put that negative in for 2. It's okay.
Mm-hmm.
Nice job.
Thank you.
Absolutely. Thank you for trying that. I'm going to actually pull all the groups back now. Is that okay?
Yeah, that's fine.
Okay. Thank you, Savannah.
Mm-hmm.
All right. Let's see here. Got messages coming in. Breakout rooms. Okay, so there's 3 people still in their breakout room. They should have gotten the message. All right, so that was new for everybody, right? I haven't made you guys work together on the Zoom yet. So thank you for those of you who really put in some effort and tried this. And thank you to everyone for even just taking that step and talking to your partner, even if it was just on chat. That's still better than nothing, isn't it? Let's go back to this. So some of you finished all of the 6 inputs. High five to you folks. Some of you got 1 or 2, and some of you got, somewhere in between. I'm glad to see you're all practicing and trying and sending me and talking with your partners about that. Let me do this. Okay. So I'm going to go through and show you all of these real quick. And then I've got some homework problems I want to write down for you to try on your own today. You can do them with a friend. You can do them on your own. You can check your work online for all I care, but I want to see you trying it out on your own. So anyways, that's later. So let's work through these and we'll see your work, compare it to what I get, and hopefully we get the same thing. And if I make a mistake, you tell me. Okay, so I'm going to make a table. I like to kind of organize all this stuff with a table. And look at that. I called it Y. I should have called it f of x. So I'm going to fix that right now. Okay, so our inputs are going to be everything from our list. And we've got to practice some negatives. So let's start with those. So plugging in -8. Now here's another thing about function notation. We keep track of our inputs. So f of -8. That's how we say that. F of -8 is equal to. Now I am going to go through these a little faster than normal. Okay, so -8 times 3, -24/2. It should come out to -12 plus 4. Double check my work. Maybe I'm missing something or doing something wrong, but double check what you got against this. And tell me if I'm doing something wrong. Tell me if I missed something, please. It happens to everybody, including me, definitely me. All right, so we got, I think this comes out to -8. -12 plus 4. Remember the space between 12 and 4? That's 8. Who's ever bigger has leftover sign. So the 12 is bigger than 4. So our answer is -8 because the negative was bigger. So f of -8 actually gives me -8. Interesting. Okay, now let's try plugging in -4. I'll box this work so it doesn't bleed into the other work. Okay, so here we get -12/2. So we get -6. 12 divided by 2, 6. -6 plus 4, -2. So we plugged in -4. We got out -2. All right, last negative. We're going to plug in -2. Okay, here's a quick shortcut. We're multiplying on the top 3 times 2, right? And that's 6. So we can write it out that way. But also, you might have noticed, we've got the 2 numbers on top. They're being divided by the number in the bottom. And at this point, before I even make it a 6, we've got 2/2. Well, technically, it's -2/2, right? -2/2. So 2/2 itself cancels. So you're allowed to do this when you're like working with your fractions. If you can cancel stuff out before you even multiply it, do it. It'll save some time. However, the negative doesn't go away. The negative's still hanging around. So we get negative 3 plus 4, which is a positive 1. Zero is my favorite because it's going to knock out that multiplication altogether. F of 0, 3 halves times 0, and just cross the whole thing out. And we're left with plus 4. 0 is our favorite because of that. Now plug in 2, and check this out. We're going to get the canceling again. 2 over 2. Cancel, cancel. 3 plus 4 is 7. Plugged in 2, got out 7, and our last one is going to be 10. Let's double check. F, plug in 4. 4 over 2 is 2. If I do the multiplying, we get 3 times 4 on top, so that's 12 over 2. 12 divided by 2 is 6. 6 plus 4 is 10. So there's our answer in a table format, right, on the right side of the screen. And if we wanted to write it out, you will just take your outputs and list them off with those nice curved fancy brackets above. Range is equal to this list, -8, -2, 1, 4, 7, and 10. Okay. Now, I had some other examples ready to go, but it's almost time, so I think we should just call it a day. I talked about this already earlier. So these are just other examples that I took from the mastery test and the post test. But I thought these were actually easier because we're just having one input. So real quick, let's look at this example together. Because there are problems like this that we'll do later in our post test. They give us a function. It's not an f though, is it? This is h of x. H of x is equal to -49x minus 125. It says at the beginning, find the value of h of -67. That means we're going to plug in 67. -67. Whatever that number is, that's our x number. So this is just like what we've been doing, except there's not a whole domain we're plugging in. It's just a single number, a single x value. Plug in -67 for x, get out an answer for h of x, or h of -67 output. I guess let's do it real quick. Let's see what we would get here. So this means I'm plugging in that number, -67. So let's do that here. Big numbers. I don't know what all these are by heart. So I'm going to use my calculator. -49 times -67. Negative times a negative makes a positive. So we get 3283. 3,283 minus 125. 3158, some gigantic, crazy sounding number. But that's it. We're all done. We did our input. We got our output. And the majority of questions are like this, but I did want to practice with the longer ones with you today. Because if you can do problems like this, then we should be able to do the ones that have just a single input as well. Okay. So I think we're going to stop there for today. Now, write down these two problems. And just a reminder, this is not a mastery test. This is your homework, but you're going to do this on paper and send me a clear, readable picture of your work and your solution. Now, I did make two problems, and they are both the same type of thing. So what's important to have written down is we're finding the range of this function given this domain. Those are our list of inputs to go in the function and get a list of outputs. Copy down number 2. It's a different equation with different domain. Now, you don't have to have this like 100% to get credit. I want to see you try. I want you to get it right, but I also want even more so just to see you try. So for those of you who may be worried about like, oh God, I don't know if I'm going to get these right. I don't want to send this to him if I don't have it all finished and all correct. Please don't worry about it. I don't mean to put that pressure on your shoulders. I just want you to try. So if you only do the first one, I'd like to see you try both, but I'll be happy to see you just attempt both of these. Okay. So you don't have to have them correct, but at least I want to see you make an effort and try. Send me a picture of your work to my Google chat. Once you've copied these down, you can go for the day. Let's see. Let me just get your attendance quick. Chase, are you here? Chase?